All right, let's look at the ODE, exact equations. All right, number 5. If the differential form is exact, then find the function phi of x comma y, so that the phi of x comma y equals c is an implicit solution to the associated differential equation. All right, so let's say here the function in front of x is I'm gonna call it the m of x comma y. Alright, then function in front of dy, I'm gonna call it the n of x comma y. Right? To verify that this is an exact equation, we can just verify that the partial derivative of m with respect to y is equal to partial derivative of n with respect to x. Alright, so let's check that. So partial derivative of m with respect to x would be, alright, so we're gonna get, actually with respect to y I meant, so I'm gonna, let's see here, with respect to y. Alright, so you can see that 2x is just going to be a constant, put that there. And partial derivative of y is 1, so it's actually just 2x. Alright, and then let's find the partial derivative of n with respect to x. Alright, so this is going to be, alright, partial derivative of x squared would be 2x. And partial derivative of negative y squared with respect to x would be 0, because y is considered to be a constant. Alright, so here, since we have the same thing, so we have partial derivative of m with respect to y is exactly the same as partial derivative of n with respect to x. Right? Therefore, this guy is exact. Alright, so this is an exact equation. So we want to find phi, so let's see, we're looking for phi of x comma y such that, alright, so corresponding differential equation would be a partial of phi with respect to x dx plus partial of phi with respect to y dy is equal to 0. So we just need to match the first guy, so partial of phi with respect to x with m, and the partial of phi with respect to y with n. Alright, so we have, so partial of phi with respect to x is equal to m. So you have 2x y. Alright, so if that's the case, we can get the recover phi by simply taking the antiderivative of 2xy with respect to x. Alright, so this is going to be, alright, so y is just a number, so I'll just put the y. Antiderivative of 2x is x squared, right? But plus some constant. But remember, this is going to be a partial derivative, partial antiderivative. So anything that has y in it will be considered to be a constant. So it could have a function of y. So I'm going to call it g of y. Right? So we have to find the g here. All right? Then next condition is we have to make sure that the partial of phi with respect to y is equal to n. All right? So let's see, I'm going to take the partial of what we found with respect to y, alright, So partial of x squared y with respect to y would be just x squared. Alright? Then partial derivative of g of y would be just the same thing as g prime of y. Alright? Remember that this has to be exactly equal to n, which is x squared minus y squared. Alright, so since you have x squared on both sides, I'm going to cancel those out. So we have g prime of y is equal to negative y squared. Alright, so we can recover g of y by simply taking the antiderivative of negative y squared with respect to y, right, which is equal to negative y cubed over 3. Right, so this is just a power rule. Right, you can put plus some constant, but in this case it's not going to really matter. Alright, so therefore we found the phi of x comma y, which is equal to, alright, so you have x squared y. Alright, g of y we just found that to be negative y cubed over 3. And then this is equal to some constants. So you can see that there's a form here. Right, so you have an implicit solution here. So it's equal to some constant c. Alright, so this is the implicit solution of the given exact equation. Alright, that's it. I hope that this was clear.